Today we're going to deal with vectors and mechanics. What is a vector? A vector is a quantity which has both magnitude and direction. Here are some examples of vector quantities. Displacement is distance in a particular direction. It has unit meter. Velocity is the rate of change of displacement, unit meters per second. Acceleration is the rate of change of velocity, unit meters per second per second. Force or weight is described by magnitude, direction, and point of application, unit Newton. Now what is scalar? A scalar quantity has magnitude only. Here are some examples of scalar quantities. Distance is the measure of length, and it has unit meter. Speed is the measure of how quickly a body moves. It has unit meters per second. Time is the measure of ongoing events taking place. It has a unit seconds. Mass is measure of the quantity of matter contained in an object. It has unit kilogram. Scalar quantities are always positive when considering motion in a straight line. One-dimensional vector quantities can be positive or negative. I and J notation. What does this I and J notation mean? J is in the y-axis and I is in the x-axis, moving 2 units. In the y-axis, it's 2j, moving 5 units. In the x-axis is 5i. Now what is this two-dimensional vector in the form AI plus BJ and triangle law of addition? If this one is the head and this one is the tail of the vector AB, then this one is the head and this one is the tail of the vector BC. So it will go from head to tail, from head to tail, and then again from head to tail. And finally for the AC vector, it will be the sum the I and J and it would be in the opposite direction. If it had been cyclic, then it would have moved like this, but it's in the opposite direction. So we call this as the resultant vector diagram. Now let's look at number 2. Girl cycles 4 km due west and then 6 km due north. Calculate the total distance she has cycled and her displacement from her starting point. So first of all, we need to draw the diagram. Head to tail, and then again head to tail, and it would be in the opposite direction. Now distance is the measure of length, so we're just going to add them up. Now for the displacement. Displacement is the change of position from its starting point to its initial point to its final point. And now you're going to use the Pythagoras theorem. That is 7.21 kilometer. Now let's look at number 3. Express the vectors v1, v2, v3, v4, v5, and v6 using the I and J notation. So v1, if you look carefully, then it is 1 to 5. So it moved 4I. And it didn't move in the y direction. So it's 0J. So we're going to write as 4I. In for V2, if you look carefully, it's 5I and 5 minus 3, that is 2J. So V2, 5I plus 2J. And for V3, so V3, so it moved 3I. It's J. 3 minus 1, but it's in the opposite direction. Like this. This one's a bit tricky. 3i minus j. V4. So if you look carefully, it's 2i. And 4 to win, that's 3j. V4, 2i plus 3j. Now for V5. So it's moved in the opposite direction. It moved from head to tail and then again from head to tail. It's better to draw a rectangle and then decides its direction. V5 minus 2i minus j. Now for V6. If we look at carefully, it didn't move any direction in the x-axis. So it's 0i, and its direction is in the opposite, and it's 3 units, so it's minus 3j. Now we're going to do 3b, when v1 plus v2. So earlier we found out that 4i plus 5i plus 2j, that's 9i plus 2j. Now v4 plus v5, 2i plus 3j minus 2i minus j. This one gets cancelled out, that is 2j. Then number 3. V6 plus V1 plus V5 minus 3j plus 4i plus, that's minus 2i minus j. That's 2i minus 4j. Okay, let's look at number 4. Find the magnitude of each of these vectors. Now we have a formula for magnitude. That's AI plus BJ A square plus B square. We're simply going to square the coefficient and add them up. So let's do number H. If we put it in the calculator, then its answer is 4.1. Number 5. A equals to 2i plus 3j, b equals to 3i minus 4j, and c equals to 5i minus j. Find the exact value of the magnitude of a plus b, 2a minus c, 3b minus 2c. So let's do number C. If we simplify it, then we get minus I minus j. $10.1. We put in the calculator and its answer is 10.1. Now number C, 6. Find the angle that each of these vectors makes with the positive x-axis. Okay, let's do number D. First we'll need to draw the triangle. Head to tail, and then again from head to tail. Now we are going to use tan. The angle it makes with the x-axis. This is the sum of the vector, and this is the angle it makes with the x-axis. So tan theta is 4/2. So theta 63.4 degree. Number 7. Find the angle that each of these vectors makes with the positive y-axis. Let's see number D. So that's the angle it makes with the y-axis. This line. So we're going to use theta. Tan theta So this is the total angle it makes with the y-axis. So if we draw it a bit precisely, so that's theta, and that's the angle from its y-axis. So this is the total angle it makes. With the y-axis. So 90 plus 14, it's 106 degrees. Okay, there's 3b. Given that a equals to 2i plus 3j and b equals to 4i minus j, find this in terms of I and j. So we're going to do number H. If we simplify it further, then we're going to get it minus 8i plus 9j. The question 2. Given that a equals to 2i plus 5j and b equals to 3i minus j, find a lambda if A plus lambda B is parallel to the vector I. B mu if mu B plus mu if mu A plus B is parallel to the vector J. So let's do number B. So here in the B part, it says it's parallel to the vector J. That means the I vector coefficient is 0. So 2 mu plus 3 equals to 0. Mu minus 3 by 2. So number 4. In this question, the horizontal unit vectors I and j are directed to east and to north respectively. Find the magnitude and the bearing of these vectors. So we're going to do number 2. So first let's find its magnitude. 𝗘𝗱𝗲𝒄𝒕𝒆𝒓 is the answer if I put it in the calculator. Now for the bearing. It means the angle it makes with the north. So this one is the north, east, so this is somewhere here. That is the direction J and 2I. So this one is the angle theta. Now we're going to use tan. Now bearing is from the north, starting from the north to this point. Now if this is theta, and we know this hole is 90, so bearing is 90 minus 27 plus 180, which is 243 degrees. 3C. Question 1. Find the speed of a particle moving with its velocities. Now for finding the speed, we're going to find the magnitude of the velocity. Speed is the magnitude of velocity. So we're going to do number D. And don't forget to give the units. Now number 2, find the distance moved by a particle which travels for the following. So let's do number 2. So first of all, we're going to find its speed. Now for the distance, we have the time given. So we're just going to convert it in seconds. So distance (972 meter). So let's look at number 3. Find the speed and the distance traveled by a particle moving with the following. So let's do number D from here. So let's find its velocity. Magnitude of velocity gives speed. And the time is given. So if we put it in the calculator, then it's 234. 23,400 meters. We need to know about this formula, that is R equals to R naught plus Vt. R naught is the initial position and R is the position factor. So let's do number 10. So this one is 7i 7i minus 13j. So we're going to do number A from here. If we simplify it further, then this is our answer. And we have used the formula of R equals to R naught plus Vt. Now let's look at number 2. A particle moving with speed v meters per second in the direction d has velocity v. Find v for this. So let's do number J from here. So this one is the direction vector. Now we're going to find its magnitude, and we have given the speed. So we're just going to multiply this with the speed to find its velocity. So if we simplify it, then this is the answer. So question 4, a particle P starts at the point with position vector r0. P moves with constant velocity v meter per second. After t seconds, P is at the point with position vector r. So let's do number J. Find t if r not equals to 4i plus j, r equals to 12y minus 11j, and v equals to 2y minus 3j. We're going to use this formula, r equals to r naught plus vj. So if we simplify it further, then this one is answer. T equals to 4 seconds. Now let's do number 5. Find the velocity and the speed of P after t seconds in these cases. Let's do A. We're going to use this formula, v equals to u plus at. So if we simplify it, then it is 7i plus 9j. And if we find the speed, we're going to find its magnitude. That is 11.4 meter per second. Number 6. A constant force F Newton acts on a particle of mass 4 kg for 5 seconds. The particle was initially at rest, and after 5 seconds it has velocity 6I minus 8j meter per second. Find F. So we're going to use this formula, F equals to ma. So A six by 5I minus 8 by 5j meter per second square. So F equals to 4 into 6 by 5 I minus 8 by 5j, which is 4.8 I minus 6.4 J Newton. Let's look at number 7. A force 2I minus J Newton acts on a body of mass 2 kg if the initial position of the vector is I plus 3j meter per second. Find how far it moves in the first 3 seconds. So it's basically like the 6. V equals to this one's half. So 3 by 2 J meter per second. Let's look at number 8. At time t equals to 0, a particle P is at the point with position vector for I and moving with constant velocity I plus j meter per second. A second particle P is at the point with position vector minus 3j and moving with velocity v meter per second. After 8 seconds, the paths of P and Q meet. Find the speed of Q. So let's find R. or we can simplify it more. That is 4 by 3 I plus 1 by 8 J meter per second. Now we're going to find its magnitude. So the answer is 1.92 meter per second.